Welcome back to this week's lecture on the scientific revolution. And this scientific revolution generally dates from about 1500 to about 1700, but of course it never really ends. This revolution had a massive impact on the West and sort of in world history, and of course it's still impacting us today. And as you probably have guessed from the times I just given you, 1500, that dates to about the Protestant Reformation that was taking place in Europe. And it's no coincidence that the scientific revolution is directly tied to the Protestant Reformation for reasons that we'll talk about in the lecture. There are a few things we'll focus on in this lecture, and probably one of the most important developments in the scientific revolution was the development of the telescope. That was used especially by Galileo, as we'll talk about, for looking up into the sky and seeing things that people hadn't seen before. We'll talk about new math, especially in terms of Isaac Newton. We'll look at a little bit of information on what's happening in terms of development knowledge of the human body. And I won't really look at new navigation devices in this lecture, but I will give you a tag so you can look up some information in case you're interested in that. I want to start off giving you a little bit of a background on the history of science, and it goes all the way back to the ancient Greeks. And one thing to remember as I'm talking about this is that the Greeks who were developing all of these new ideas in science were really reliant on their senses. So what they could see, what they could hear, what they could taste, and so on. So they didn't have machines that could help them. They really didn't know a lot about the laws, the scientific laws that govern our universe. But of course, they're some of the earliest ones to start thinking about it. And what I should have done on this slide is put Democritus first because he's the earliest. So his dates are 460 to 370 BC. And he came up with the idea that, is fairly common today, that all matter is composed of little tiny objects called atoms. And this atom could not be divided up anymore. So you've got the Greeks thinking about that, which is something very common in our society today. Now, moving forward, you've got Plato. Plato wasn't the biggest influence on science, but he certainly got the ball rolling in terms of thinking about what your senses can tell us. So what we see and what we hear and what we taste and so on. He didn't totally trust the senses. So in fact, what he did was he made up a little story that allowed people to think about what the senses might not be telling us. And one is his very famous story of the cave. So he told a story about how some people might have been born in a cave and couldn't see anything because it was dark. So all they knew is really what they could hear and the darkness that they could see. Now he said, imagine if someone opened up a door behind them and stood in front of it. These people living in a cave would see light for the very first time, and they would see the shadows of the people standing in the doorway. But for the people in the cave, those aren't shadows, those are real objects. So Plato said, this is why we can't really trust our senses to tell us everything that's going on, because how do we know, as modern day people or people living during the time of Plato, that what we see aren't shadows like what these cave people saw? Then along comes Aristotle, who was the biggest influence on science in the West. And what Aristotle did is he started to develop theories on what made up the world. And he's borrowing these ideas from other people as well. He was one of the earliest ones to write these down. And it's ideas that we use today. So he wrote about the three basic states of matter. So where you've got solid, liquid, and gas. And you can think of water like this. You can get solid water, which is ice, liquid water, and then gaseous water that goes to steam. The Greeks also realized that everything, or at least what they said, was made up of four elements. And you might have heard this. There's lots of earlier societies that talk about this. The four elements: fire, water, air, and earth. And what they did was they made tables of what things were made out of. So you've got something like wood, which is made out of water, air, and fire because it could be burned, and so on. So they were, again, trying not to use value judgments about what we know about science today, but they were some of the earlier pioneers in trying to figure out what makes up the earth. The Greeks also had ideas on the place of the earth in the universe. And what you're looking at here on this image is something called the geocentric theory. And what you've got here is the Earth at the center. So that's the geo. Centric means center. So the geocentric theory is the Earth is the center of the universe. And then all the stars and the planets, which the Greeks knew about, circled around the Earth. And for the Greeks, this made sense because what they did was if you pick up anything, it drops to the Earth. It doesn't float up into the sky and go towards the sun or go towards the planets. So for them, they said this proves that the Earth is the center of the universe. And of course, they also thought about what holds up the moon and the sun and the planets and the stars because they didn't have an idea of gravity. And so they came up with this idea that there's something called ether, which is a sort of thickish substance that things will float on. Now, moving forward from the Greeks into the early Christian period, the church really liked this idea. So they said that the earth was the center of the universe because, according to them, God created people on the earth. He didn't create them on the sun or the moon or anyplace else. So the earth must be special and that it sits at the center. So what you find is that the church wholesale took over Aristotle's ideas of this geocentric theory. Now, part of the downfall of this whole idea of the earth being the center is something that happened during the Renaissance, which is where you've got new Greek and Latin texts coming out, where ancient Greeks and ancient Latins actually argued with Aristotle and said, no, he isn't quite right. And what this did was this made the Europeans start thinking about whether this particular theory was correct or not. And as I put down on the bottom of the slide, you get some new things happening during the scientific revolution that included things like skepticism, not quite believing what you're told, which of course is the earth is at the center of the universe. You also have free thinking, meaning people started thinking differently about where the earth was actually sitting in relation to the sun and the other planets. And of course, a big part of the scientific revolution is experimentation. So all these things put together, including the Renaissance and the Reformation, made people think differently about the earth. And this went against the church. It's a really important part to remember, especially when we talk about Galileo in just a bit, who is a Catholic, and he comes out with the heliocentric theory, which is the sun is at the center of the universe. And the church did not like this, so he ended up getting into lots of trouble. Now what I want to do is just focus on astronomy for just a bit. Ancient astronomy also goes back to the Greeks, especially with a man named Ptolemy, who lived between 90 and 168 AD. He had this idea that the earth was at the center and that all the planets and the moon and the stars all circled, and the sun circled around the earth in perfect spheres. And as I just mentioned, the church definitely used these ideas. Now, Copernicus, what he ends up doing is, with his naked eye, making a whole bunch of charts on movements of the stars and the sun and the planets. And he came up with the idea that the sun was actually at the center. And this is something called the heliocentric. So helio means sun, and then centric means center. So the sun is at the center of the universe. And he ended up writing a book called Concerning the Revolutions of the Celestial Worlds in 1543. And this book played a massive impact on later astronomy and later ideas on where the earth actually sat in terms of the universe. You also have some students of Copernicus, and these are Tycho Brahe and Johannes Kepler. And let's talk about Brahe just for a little bit. So Brahe was an astronomer, and again, using his naked eye because you didn't have the telescope developed during this period, tracked the orbits of the sun and the planets. Now, he kept all of these charts. He unfortunately didn't quite know what to do with these, and he definitely believed that the earth was still at the center and unmoving, so as opposed to Copernicus, who thought that the sun was the center of the universe. So Brahe made all these tables. Now, a couple things started happening. So in 1572, there was a new star being observed, which shocked everybody. This new star was probably a supernova, but the idea is that the earth is sitting at the center. You've got the moon and all the planets and the sun. those are moving in perfect circles and the whole universe is perfect. Now, well, you've got a new star. This meant that things in the universe can change. So it got a lot of people thinking about what is happening. Brahe's work was continued by Kepler. And Kepler was an astronomer and a mathematician. And what he realized, which was extremely important, is that the planets, the moon, stars, everything else, they're not moving in perfect circles. They're in ellipses, so an elliptical orbit, which of course is one more piece taken away from the idea that the universe was totally perfect. So you've got people talking about the idea that the planets are now moving in elliptical orbits. You've got new stars coming out. We'll talk about comets in just a bit. And then you've got the development of the telescope. Now, Galileo did not discover the telescope, but he actually made it better. And what he ends up doing is looking up to the sun. And the sun was supposed to be this perfect body, and what he could see are sunspots. Now, of course, I wouldn't recommend doing that because you should definitely not look at the sun with a telescope without a screen. But anyway, he looked at that and saw things moving on the sun. He pointed the telescope to the moon, and what should have been a perfect body wasn't. He could see craters. And probably the thing that really got him most excited about is that he turned his telescope to Jupiter. And he saw that Jupiter had little moons that circled around Jupiter. So adding all of this up, Galileo said that the sun was definitely at the center of the universe and everything moves around it, including the Earth. So he wrote a book called The Starry Messenger, and this put forth his ideas on the heliocentric universe, that the sun is at the center. And as we'll see next, he got into a lot of trouble for this. And sorry for the amount of text on these slides, but this is part of Galileo's trial because, as I said, he got in trouble for saying that the sun was at the center of the universe and not the Earth. So what I'll do is I'll put a tag here, and you can read some of these primary texts instead of trying to read them on the screen. And this is the case for the next two slides. And of course, if you want to read them, just turn off the video and then start it up again for the next scene. So as you've read, Galileo actually recanted, meaning he took back everything he said. So he said, I believe that the Earth is the center of the universe and not the sun, and I'm very sorry for this. As you can see from this slide, it took until the year 2000 for the Catholic Church to apologize for putting him on trial and saying that he was wrong. But Galileo's ideas really are the very beginning of the scientific revolution, and from that point onward, things move fairly quickly in terms of new technologies, new ideas. And what we'll look at next is Isaac Newton, who had probably the biggest impact on the scientific revolution. And Isaac Newton is the most important person in the entire scientific revolution period. And as I put here on the slide, he's actually the beginning of the Enlightenment, which we'll talk about in just a bit. Anyway, Isaac Newton, so there's this story about him having an apple fall on his head, and he discovered gravity. We're not quite sure if that's true, but he certainly developed a new math called calculus, which we all know today, and to think about the idea that the sun is actually at the center and what all of this means. So what Isaac Newton did, he took the tables from Brahe and his ideas from Kepler and Galileo, and then created a new math which would explain all of this. Now this is really interesting because now you've got the universe being explained by math and not by the church. And this is a really important point to remember because, as I said, the scientific revolution definitely comes out of the Protestant Reformation and all the problems were happening in the 1500s. But he prints his book on the principles of mathematics, and this book is really the beginning of everything. So people all over Europe read his works, and it gets people to think about science and the human body and the world in general very differently. I don't want to spend too much time on this, but I do want to mention that some things were happening in terms of the scientific revolution in the field of medicine. So Medicine also goes back to the Greeks and Romans, and of course other civilizations are thinking about medicine as well. But Galen in particular, and I've given you his dates here, he was an early doctor, if that's what you want to call him. He had all these ideas, and one idea which was really interesting is that blood just sits in your body. It gets absorbed back in to the same place that it's being used, so it's sort of continually being refreshed, which obviously we know is not the case now. And part of what we know about blood and things like that and the heart pumping comes from William Harvey. He was investigating the circulatory system, and you can see his dates. He fits in perfectly with the scientific revolution, and he discovered that the heart actually pumps blood from one side to the other of your body. You also have another man named Vesalius, and he was doing some early autopsies, and he wrote a book and did all the drawings for a book called De Fabrica. And you can still find this book on Amazon in case you're interested. Anyway, you've got William Harvey writing on the motion of the heart and so on. So medicine was definitely a big part of the scientific revolution. Okay, now let's just talk a little bit about science and what it actually is. You've got a couple people early on who are trying to figure out how you start a scientific investigation, and one is Bacon. And he did something called the inductive method of reasoning. And what this essentially is you start off by seeing something or looking at something, and you jump off from that point. So you've got observation of something that's happening, and then you move onwards from there. And René Descartes is a really good example of this. I'm sure you probably heard this phrase, I think, therefore I am. So what Descartes did is, for his beginning of scientific investigation, is going all the way back to himself. Like, how do you start off with the most basic information you can get? And for him, it was, I think. And then from I think, he said, I am a person. And then all the other investigations from that go outside of him. Another way is something called deductive reasoning. So what you do is you establish something, and then you move one step above that. And if it fits into the general pattern, then you move one step above that. And if it doesn't fit, then you have to move back one step. So that's deductive method of reasoning. These are two ways, so inductive and deductive, that people were doing scientific investigations. However, it's Newton once again who puts these two together. So he combines deductive and inductive and comes up with what we call the scientific method, which if you've ever taken a science class, you know this is the way you do that. Everything you know starts at a certain point and it moves outwards from there. And you do this by observation, by testing it, and experimentation, which of course is the testing part. And everything that comes after has to fit. So as you can see, this is a combination of deductive and inductive. And it was Isaac Newton who put these together. And again, this is what we do when we do science. It's a scientific method. And this is our last slide for this lecture. And what I want to talk about just really briefly is the spread of knowledge. So we've got a couple of different ways this happens. One is scientific societies. And once new sciences started to get developed, many countries realized that this information was really useful in terms of just technology in general. So what countries started to do is actually pay for conferences. So if you ever go to a conference, you know what happens. You either present and you teach the audience what you're learning about or what you have studied, or you're sitting in the audience and you're learning about what this person has presented. So that's a scientific society. And these, again, were paid for by governments, also by private individuals. But this is how learning was spread through a society. Another way, which is really interesting, is called a salon, or the salon system. And this would take place, or these would take place, in living rooms. And this is really interesting. A lot of women were involved with the salon system. So a woman would invite a whole bunch of people, men and women, into her house, and she would say, okay, tonight we are talking about Galileo and his idea of the heliocentric system. And so people would sit around and debate, and they would discuss all of these new ideas. Newton could be discussed. Any of the things that we've talked about could be discussed in the salon system. So these are two major ways that knowledge was spread during this period, scientific societies and the salons.